See, that's all it is now. It's just an orange glow. That's all I can see. But the sun just coming up. Better not be. It's awful early. Awful early for the sun paper, Joe. I don't think the sun would just be in that one spot. I think it's moving out, you guys. Oh, we'll watch it. We moved up to a higher vantage point, so you tell us what it does. Well, listen. Sounds like it's revving up its engines. Can you hear it? I hope. It's sure cold out here. I hope you're taping this, you guys. Yes, we are. Sounds like to me a power plant diesel motor and a screeching noise in between it there, or with it. Okay, we're listening. 4:29 a.m. That's for the record.
Delta Sierra Juliet. It's not an aircraft. Can you describe the aircraft? As it's flying past, it's a long shape. Cannot identify it. It has such speed. It's before me right now, Melbourne. How large would the object be? Seems like it's stationary. What it's doing right now is orbiting. The thing is just orbiting on top of me. It's also got a green light and a sort of metallic, like, it's shiny on the outside. It's just vanished. That strange aircraft's hovering on top of me again. It's hovering and it's not an aircraft.
We have two pieces of equipment. One measures the signal we're listening to in the time domain, the top one here. And the bottom one is measuring the frequency components of the signal.
Yeah, what does this mean when they're all together like that?
What you have is you have many tones happening at the same time. And right now, they're aligned. Now they're disaligning. Out of alignment.
Showing this throbbing, modulating beat that we hear on the tape. This beat, or modulation, occurs at these frequency peaks. Each one of these peaks is a discrete frequency. If you wanted to give a visual display, let's say we're talking a motor. Could be a motor, a shaft of a motor with 4 magnetic poles or coils around this shaft. The curious thing about this, it changes from 4 to 5, 6, 7, all the way up to a number that is difficult to discern. At a certain point, you're going to generate a certain amount of magnetism. And then later on, you want a stronger field, well, you're going to select 8 fields. All right, now you're going to hear 8 pulses on the tape. And then later on, you want a stronger field, you can select 16, 32.
Is there anything unusual about this?
I would think it's highly unusual. I don't really see any application for it, with the exception of, like I say, either generating a magnetic wave of some sort for laboratory purposes or maybe in this case, propulsion.
Also, another interesting point to note here is we have a steady, there seems to be a steady pattern all throughout all of this random signal. It seems to be a level change very steadily in around 5 to 10 cycles per second, which happens to be in the area of the natural magnetic resonance of Earth, also called the Schumann resonance.
Is that significant in any way?
It could be. It's just interesting to note the correlation there.
The peculiar correlation is something strange.
I mean, why would the correlation be there?
Yeah.
You can see it on the oscilloscope.
Meier says the beamships can ride the magnetic field of the Earth. Rognerud's findings seem to bear this out.